I'm going to explain in this video about mapping functions. So what is mapping functions? Before that, in my previous video, in the locality of reference, copy back, in copy through, in that video I explained the concept of cache memory or importance of cache memory, how the cache memory improves the speed of the main memory. That is so we know what. So we are having main memory. We are having main memory. So then we are having what? CPU. So CPU is responsible for executing everything. So we have stored our programs to be executed. In what? In the main memory. In the main memory we are stored. Now, whenever CPU, suppose I want to execute this so and so program. So now CPU has to get this program. So instead of taking program every time from the main memory, what it will do? It will make some cache memory and it will bring the statements, block of statement. Don't bring only one statement. From main memory, it will bring some blocks of statement. That is group of statements. Okay, into the cache. And whenever CPU wants to execute that instruction, any instruction, first CPU checks in the cache memory whether it is present here or not. If it is present in the cache, it will take from here only. If it is not present in the cache, then go to the main memory, bring from main memory to the cache, and then from here to text. Okay, so when it is taken from here, it is in byte terms, it is in block terms. This is already explained in my previous video. Okay, now what is the problem in that? So now the problem in that main memory is a huge memory when compared to the cache memory. Now today, in our systems, whatever the systems we are using today, nowadays, that systems, generally what we are using in our main memory, in our mobile also we are using nowadays 6 GB or 8 GB RAM compulsory we are using. Let us take 6 GB memory, we are using main memory. 6 GB. 6 GB means we are using, that means there will be 600 crores. 600 crore location will be there in our memory. That means like this. So it's 600 like this. 600 crore different locations will be there. Okay. In main memory, if you are using 6 GB, if you are using 8 GB, 800 crore locations. If you are using 2 GB, 200 crore locations. That many locations. But our cache says, especially this is L3 cache. Okay. This is the secondary cache. So this cache, generally it is in terms of 1 MB. Cache size is in between 1 MB to 8 MB maximum what we are using nowadays in our system. Now let us say 1 MB. 1 MB also means, suppose if I take not 8 MB, let us take I am using 1 MB cache memory. Means 1 MB means 1 into 10 to the power of 6. 6 bytes. Okay, 1 into 10 to the power of 6 means 1, 2, 3, 1, 2, 3. That means now 10 lakh. That means 10 lakh locations. 10 lakh locations will be there in our cache memory. See, where 600 crores, where 10 lakh locations. That means this is very, very small. Now, for example, now let us take my cache memory. For example, see that much huge difference. 10 lakh locations I'm having in here, cache, 10 lakh locations. Here 600 crore locations. Now let us take for an example, now this is my main memory. Let us take for example, it is having some 10,000 locations. 10,000 locations. Okay, so 10,000 locations. Now let us say this is 0, this is 1, 2, this is the last one is what? 9,999 locations. This is 10,000 locations totally. Now let us take, I am having 100 locations in what? In my cache memory. For example, this cache. 100 locations, that's it. Okay, simple. Okay, now 0, 1, 2, this is last is 99. Now what? Assume my program, whatever I want to execute, that program is there in this location, starting from this location. Okay, so let us take the last instruction. Let us take, see, this is 5,500 to 5,900. Okay, so these instructions are stored in my memory from this address to this address. 5,500 to 5,900. Now, whenever our CPU wants to execute, first it will check in where? First it checks in the cache. Assume nothing is there in my cache. Cache is empty. Now, so this cache miss. That is not there in the cache. So what will process do? First it will go to the main memory, bring that blocks of instruction and store in the cache. Assume first it will bring 5500. Assume it brings 5500 in so and so location, for example. Okay, let us take this is my instruction A. So similarly, I am having, say, let us take this is my instruction X. This is instruction M. Now assume it wants to execute instruction X. It is not there in the cache, that is cache miss. So read from the main memory and store that instruction X in 0th location of cache memory. And after some time, assume it wants to execute instruction M. So it will bring here instruction M in what? In next location, instruction M here. Like that, it will bring that one. Now, assume later on, it want to execute, after some time, again it want to execute instruction X. Instruction X. It is there, instruction X, but it is there in the cache memory. But how it will came to know? Because, see, my CPU, whenever it wants to read from the main memory or write into the main memory, it will generate address. We discussed in many of the topics. It will generate the address and it will be stored in MER, memory address register. So whenever it generate the address, so that will be some number of address. So for 10,000, for example, assume 10K. 10K means for 1K, 2 to the power of 10. That means 2 to the power of 10 is equal to 1K, 2 to the power of 11 is equal to 2K, 2 to the power of 12 is equal to 4K, 2 to the power of 13 is equal to 8K, 2 to the power of 14 is equal to 16K. That means I need 14 bits. 14 bits to identify each locations. That means my address line is 14-bit address. 14-bit address. That means it will generate 14-bit address. But that 14-bit address, that is now, this address is in terms of 14-bit, 5500, this address. That I need to match with cache address, which is there here or not. But how many locations are there? 1900. 100 means what? 2 to the power of, 2 to the power of 5 is equal to 32. 2 to the power of 7 is equal to 128. That means I need only 7 bits. That means my cache is only what? My cache is 7-bit. Cache is 7-bit address in this case, in this example. Okay. In this example, my main memory is 14-bit address. But that 14-bit address, I need to match with 7-bit address. How it is possible? See, whenever I'm matching, both should be the same. So this 14-bit address, I need to match with something. For example, let's say 14-bit. 4, 5, 4, 8, 12. This is 14-bit address. Now this bit address, now I need to compare with, say, this one. So how it is possible to match? So that is the problem. That means I need to know which block of this main memory I have brought into which block of the cache. Okay, so in order to know which block of the main memory is there in which block of the cache, okay, for that we are using mapping functions. So mapping functions tells us which block of the main memory is stored in which block of the cache memory. That is the mapping functions. So there are 3 main mapping functions we are using. So that are, so one is direct mapping and next is associative mapping and lastly set associative mapping. So these are the 3 different mapping functions we are using in order to map, so which block of main memory is stored in which block of cache. Whether, because always CPU checks, okay, checks in the cache memory only. If it is present here, or how it will not know, but it will generate memory address, but it is checking cache address, cache memory. Understand this concept. See, always CPU generate the memory address, but first it will check in the cache. So this address I need to check whether that is there here or not. To do that, we are using mapping functions. So these are the 3 different mapping functions. So these I'm going to explain in the next video. So hope you understood what is the mapping function, what is the necessity of using this mapping function, and what is the different mapping functions is available. Okay. If you have any questions, please write it in the comments. Thank you. Thanks for watching.